Hello, everyone. Thank you for joining us here for Panel 1, Session 4, Using Sustainability Strategies to Create Business Strategies. My name is John Dyke, and I'm the Chief Executive Officer of SESME, the Smart Manufacturing Innovation Institute, Clean Energy Smart Manufacturing Innovation Institute. And it's my privilege today to host this panel here and a great set of speakers. I think you're going to be thrilled by the various speakers and the presentations that are sharing with us today on this very important topic. I think the underlying challenge and the opportunity represented by sustainability is best conveyed and justified and communicated in the context of business strategies, and those two are vital to sort of remain tied at the hip, so to speak. So before we get started with our first presentation, I wanted to share a few quick housekeeping items with you, and then we'll get started. First, thank you to all of the sponsors for making this event possible, especially DTE, the host sponsor. Please click on the sponsor link on the left-hand column of your page and visit their sites to learn more about their work. As I mentioned, we have an exciting lineup of speakers. After all presentations are given, we would welcome you to join us for the last 15 minutes of the session as the speakers answer a few questions from the chat. ACEEE will collect any remaining unanswered questions and send them to the speakers to respond after the conference. With this in mind, you can see the chat box on the right-hand side of the screen. Please use this box only to ask questions for the speakers and try to refrain from engaging in dialogue with other attendees. If you would like to connect with other attendees, please take advantage of the attendee link, also found on the left-hand column of your page. Any attendee who has created a profile can be found there. In that column, you'll find attendee resources as well. The resources contain the conference proceedings, the attendee list, and an evaluation survey, which we would urge you to complete at the end of the conference. Everyone who fills it out and includes their name and testimonial will get a discount to attend the 2023 summer study. In the program participants link, you'll find information about all the presenters, including their bios and copies of their presentation as well. Last, please plan to join us at the end of the day for post-panel debriefs to learn about other discussions that you may have missed. All sessions will be recorded, though, and available on demand after the conference. And just again, to repeat myself briefly, remember to post your questions in the chat box on the right-hand side of the screen. The plan is to go through each of the three presentations entirely, which will be roughly 20 minutes each, and then we'll have at least 15 minutes to address your questions. So let's get started with the first presentation. It's with two speakers, Todd Amundsen and Eva Urbach, who will be tag teaming, and let me give you a quick synopsis of their backgrounds and where they're coming from. Todd is currently employed as an industrial engineer, technical lead at Bonneville Power Administration and Energy Efficiency, where amongst other things, he has managed the development, training, and application of BPA's measurement and verification protocols and guidelines, including in the selection guide. The body of work provides the BPA Pacific Northwest Utility Customer Service Territory with an overview of protocols, application and reference guides, and documentation for determining verifiable, reliable savings. As the BPA Energy Smart Industrial Program launched in 2009, Todd and ESI third-party contractor Cascade Energy staff worked to adapt established measurement and verification techniques to continuously measure and verify energy savings for strategic energy management at constantly evolving industrial facilities, aiming to provide an appropriate balance to risk and rigor. The present results of these efforts are the BPA ESI monitoring, tracking, and reporting guidelines. Todd currently serves on the EVO IPMVP Technical Committee and several subcommittees, as well as the Pacific Northwest SEM Collaborative Leadership Team and M&V Working Group. Todd received his BS and MS in Mechanical Engineering from the University of Portland and the University of Washington, respectively. Eva Urbach is a senior energy efficiency engineer who has spent nearly 2 decades helping federal agencies and private companies across the United States find and verify reliable energy savings. Across the way, she has seen plenty of well-intentioned projects fail to live up to their potential. Her passion is ensuring that accurate modeling and well-thought-out measurement and verification plans, M&V, make reliable energy savings projects. In her current role, Eva oversees technical quality for all custom projects submitted for approval to Bonneville Power Administration's Energy Smart Industrial Program. Todd and Eva, the floor is yours.
Thank you, John. And welcome, and thank you for joining us today. Our Pursuing Perpetual Project Performance Persistence paper and presentation takes a look back on a long-running industrial program to identify a number of industrial energy efficiency capital project situations that led to losses in projected energy savings. Yet it also shares the lessons learned and simple yet effective activities and strategies that program implementers and sites can use to ensure a persistence of energy savings. Also included are a few tongue-tying alliterative verses and tongue-in-cheek titles to those situations too. Eva and I have worked together in various Bonneville Power Administration energy efficiency related capacities for over 8 years. While Eva and I are presenting today, Sarah York played a very important part in developing the paper and continues to play a key role in the Energy Smart Industrial Program.
Hey, Todd, share your slides.
Better?
We can see them. Thank you.
Okay. Thank you for telling me. What is Bonneville Power Administration? BPA is a self-funding federal agency within the U.S. Department of Energy, established in 1937, headquartered in Portland, Oregon, with 2 core businesses, electrical power and transmission services. BPA covers its costs by selling its products and services. BPA
You need to go to presentation view, Todd.
Are we there?
Other screen. It was perfect in rehearsal, guys.
Yes. BPA markets power at cost from 31 federal dams and 1 nuclear plant, over 1/3 of electricity used in the Pacific Northwest. BPA has 142 customers, including utilities, cooperatives, federal agencies, direct serve industries, and others. Pacific Northwest power plant construction cost escalations and other impactful activities in public interest in the 1970s resulted in an energy efficiency mandate from a congressional act in 1980, a bill that was signed into law by then President Jimmy Carter, which is cited as the Pacific Northwest Electrical Power Planning and Conservation Act. This is a regional power plan updated every 5 to 6 years to assure the region of an efficient and adequate power supply, meeting load growth, and for other purposes too. The plan set energy efficiency targets for BPA and electrical utilities within the Pacific Northwest region. In context, the present industrial load in BPA utility customer service territory that's eligible for energy efficiency incentives, it may be useful to mention that magnitude is close to 1,600 average megawatts, or roughly 1,400 gigawatt hours. That is roughly 20% of the firm electrical power generated at the 31 dams and 1 nuclear plant. Wood products is roughly 1/8 of that industrial load total and spread across the region. Food processing and cold storage is roughly 1/6 of that total and primarily located in the mid-Columbia area. Pulp and paper is over 1/3 of the total, and primarily in Western Oregon and Washington. Another dozen or so segments of industry, including water and wastewater treatment, make up the remaining total across the BPA utility customer service territory. Energy Smart Industrial program launched in 2009 with Cascade Energy as the implementer to address a need to meet BPA's portion of the Pacific Northwest Power Plan's targeted industrial sector energy efficiency savings. Of the over 120 BPA utility customers, 115 are enrolled in the ESI program, which represents 99% of that industrial load. Those not enrolled have very little to no industrial customers with limited EE budget dedicated to residential customers. During its past performance, combined with expected industrial energy efficiency achievements this rate period, the ESI program has helped BPA acquire energy savings of over 10% of that overall present industrial load mentioned earlier. ESI program design and implementation has remained fairly steady and consistent since 2009. Certainly some continuous improvement efforts throughout, some from utility feedback, others from evaluation studies, but we'll dive into those details here. A long-term program such as ESI means that highly credible boots on the ground, the program partners, engineers shown here, can come back to the utility's industrial customer site several times over the years, collaborating with new and/or senior staff, involving new energy efficiency projects and revisiting old ones too. With program partner engineers, M&V work complete, reliable first-year energy savings from these implemented projects are submitted by utilities to BPA that ultimately captures these savings with all the other sector energy savings over the regional power plan, and then reports them in total to the Northwest Power and Conservation Council. Eva, please continue.
Thanks for that background, Todd. So we've got some pictures in here, and these are from the BPA archives. I want you to know these are not the sites we're going to be talking about. They're illustrative only. All right. So why did we want to write this paper? I have been in the industry for a while, and while I'm inspired by all the stories of project successes, I really feel like I learn a lot more from hearing how things went wrong. So in a lot of jobs, you're the expert. You parachute into a site, you dispense your knowledge, and then you rocket out of there. And you're left to assume that everything's going perfectly once you've left. With the benefit of the long-running ESI program, we're able to go back to sites again and again and kind of hear how some of these turned out. Another bonus for the ESI program is many of the same engineers have been here. So we mine stories from the long timers. These aren't just our stories. All right, next slide, please, Todd. So this is a bell curve because we talk about projects lasting for 5 years or 10 years or 25 years, but really we know that nothing is a point. They're not all going to fail in 2025. Some are going to fail early, some are going to outlive us all. But what we really want to do in our quixotic quest for quality is try to make them last a little bit longer. We're talking about both SCM and custom projects. I know for programmatic reasons, a lot of times we treat these as completely separate domains, but really a lot of the lessons apply to both kinds of projects. Next slide, please. So to make this system work better, where would you start? I know the engineers in the audience are probably looking at those machines and the belts and thinking about how they could reorganize them. But really, one of the easiest ways to make projects last longer is to focus on that gentleman in the middle, the people. It's not that design and technology aren't important factors. Obviously, they've gotten us a long way. But once you've done that, you really have to think about the people who interact with the projects. Next slide. So the people are really crucial to how projects are going to work. You need buy-in, both from management and operators. But the other problem with people is there's turnover. They get promoted, they quit.
Eva?
They move on. Yes? And they've also got lots of things on their mind. We work in energy efficiency day in and day out, but operators have their primary job, and then maybe they're thinking about their lunch or their kids, and maybe energy efficiency isn't top of mind. So what does motivate them? Sometimes it's as simple as just reminding people of the system that they have, how to use it, where the set points are. Sometimes it's about reminding them of the good work that energy efficiency can do. And sometimes it's money. All of these things we can use in simple reminders to keep projects performing well. Once again, it doesn't take a lot of money. It just takes a little bit of thinking outside of our usual box. So we're going to share a few stories illustrating these points. If you want more, there's more in the paper. I encourage you to go read it. All right, Todd's going to start with this story. Thanks, Todd.
Thank you, Eva. Here's a custom project of a compressed air system control strategy type that fell into the challenge bucket while ricocheting off the rim of the failure bucket. The site's a pulp and paper mill with 20 air compressors that total 3,000 horsepower and are spread throughout the multiple process areas, supplying air through a network of piping and distribution system components. Over the years, capital equipment upgrades had been implemented, but early in the ESI program existence, with energy efficiency study in hand, an assigned site project engineer had interest in management approval to implement an overall control system. The control system would replace the efforts of an employee who would walk the plant site twice daily and manually turning each inlet modulated compressor on or off to meet demand load needs. This would be upgraded by making all the compressors run load-unload with a control system that would stage the compressors to meet demand load needs. The program engineers worked with the utility and site to complete the energy efficiency custom project. Fast forward 7 years, or in between, the program engineers had worked on a number of times with the utility and site to help complete many process improvement projects, including more than one mega project. But a refocus on the complete compressed air system found that many of the compressors had migrated back to manual control. A number of challenges identified included, upon inquiry, it was determined reverting to manual controls happened when a compressor failed to meet demand, whether it was perceived or real. Operator myopia was another, where the operators would adjust the air compressors working in their area to get more pressure, which in turn stole air from the rest of the system without fixing the actual issue. And the operators were suspicious of the control equipment. They felt the system was too cheap to function adequately in an industrial environment, that the project was, in their words, commercial grade. Well, along with the successful implementation of other process improvement projects, the program engineer was able to work with the site personnel to regain most of the benefits from the original control system design. In this case, the mill had good personnel resources and a robust data historian. Spending slightly more at the outset of the control system project could have helped mitigate the challenges or issues and possibly ensure that operators were more open to letting the system do the controlling. A more robust control system strategy with centralized human-machine interface would have been maintainable and a valuable asset to building trust. And here's success story number 1. Too many capital projects rely on institutional knowledge, that is, knowledge not well documented, if at all. This can be general knowledge about the new equipment, project design intention, that is, a control strategy of air compressors to meet system needs and save energy too, or specific historical knowledge of why a project was initially implemented. Simple reminders after the completion of the project and delivery of the energy efficiency project incentive check include very low-cost ways to enhance project performance. One of these can take the form of a program-created and utility and end-user approved poster, which highlights energy efficiency projects, such as the one shown here for Alta Forest Products, a customer of Northern Lights located in the Idaho Panhandle. This helps serve as a reminder to employees, including management, of the great work the site has done, and a strategy to ensure general personnel have awareness and ownership of energy savings technologies. Eva, please.
All right. And sometimes the ownership needs to go to the owners and the operators. So this is from a vegetable processing facility in the state of Washington. It was enrolled in SEM, and they developed a protocol for compressor sequencer operations. So what you see there is a simple write-up that has the day-to-day procedures on it that's been printed out, laminated, and attached to the compressor. The other thing that happens there is the issue resolution procedure. We find a lot of times that systems, control systems in particular, get out of whack because there's some sort of upset or emergency, and all hands on deck to get the process restarted. Things get moved into manual, but maybe they don't go back to their efficient operation that's been carefully designed. A reminder like this can really help the boots on the ground, the people there, remember what they're doing and how to come back from any sort of problem. This site graduated from SEM, and I'm happy to report that an engineer went back there, and the sequencing system is still in operation today. All right, next slide. And sometimes the bottom line is just the bottom line. Money is really what can motivate a site. This site is a compressed air system upgrade at a lumber mill in Northwest Oregon. The site was using their energy efficient control system, but then with layoffs and some turnover, the energy efficiency got deprioritized. It was found that really what the site cared about was the bottom line. So this simple chart was developed that was easily maintainable, that was sent to corporate monthly, showing how much energy was being saved every month at the site. This emphasis on the bottom line really helped the site focus. It got faster response to maintenance requests and also more attention for energy efficiency projects. So sometimes we want to go and make the fanciest thing imaginable, but a simple chart is all we really need. Okay, Todd, bring us home.
Thank you, Eva. In conclusion, a long-term energy efficiency program with continuous personnel, such as the ESI, can contribute to the long-term success of implemented projects. With changes of ownership and or site personnel change occurrences, the project knowledge does not get entirely lost. This can apply to both custom or capital projects, as well as those leaning more on the operations and maintenance improvements side or strategic energy management projects. While surely there's more ESI program learning to be had, this presentation identified several situations that led to loss of energy savings for custom projects, while also sharing lessons learned that program implementers and sites can apply to ensure persistence of energy savings. These include, as mentioned earlier, program continuity, creating or updating standard operating procedures, creating and displaying signs with clear and simple reminders for current and future operators. When continuous monitoring by sub-metering or an energy management information system isn't practical or an option, the use of an existing control system to provide operators with system-level visibility. Ongoing tracking of key performance indicators or the cumulative sum of energy savings. And using measured and verified energy savings information, translating that to cumulative money savings reports for site staff to communicate with other employees and management. And celebrating success, such as creating and displaying project success posters. Initial operator training to increase comfort with new systems, and then repeated training over time to help remind personnel with multiple competing duties. And the simple offering of lunch and learn type webinars for interested parties. In the field of energy efficiency, as in life, there are things that can and things that cannot be controlled. While optimism about energy efficiency project success is helpful, considering ways that projects can fail with early thinking about preventative strategies can reap great benefits in the pursuit of perpetual project performance persistence. Thank you.
Thanks, Todd and Eva. I thought that was a phenomenal presentation. I have probably a half dozen questions myself to ask, but that's not my job to do today. But I do want to encourage the audience to type your questions into the chat box on the right-hand side. This is your opportunity to get your questions into the queue and make sure we have the opportunity later to address them. So please don't forget to do that. Next, I'm pleased to introduce you to Zach Padel Aberhart. Zach is a product manager at Cascade Energy, where he helps multi-site enterprises and utilities scale their energy management programs. Zach has 11 years of experience providing technical consulting services and innovative energy management program design for Cascade Energy's clients across North America. A mechanical engineer by training, Zach currently leads product development for Cascade's software and programs. So Zach, the floor is yours.
Thank you, John. And thanks to Todd and Eva. Let me just share my screen here. And I'm going to continue with the storytelling that in the same vein as Todd and Eva. I'm going to talk about a case study of how Sysco Foods, the global food service leader, has cut their energy use in half. And given that most of us in the energy efficiency world get ecstatic about 5% or 10% gains, 50% savings is simply astounding, and it's worth exploring further. So just for a little more detail, Sysco's energy management program includes 142 facilities across North America. They've cut their energy use in half per unit of warehouse volume since 2006. And along the way, they've avoided spending over $300 million in energy costs that they would have otherwise incurred. So these results are truly impressive. And I tell this story with Sysco's help as a product manager at Cascade Energy. Since 2006, my colleagues at Cascade have designed and implemented Sysco's energy management program. And the credit for these impressive results go to the many folks at Sysco and the supporting cast at Cascade who have worked on this program for years, and in many cases, the same people since the start in 2006. And when we tell this story, people often ask about the efficiency measures, or the equipment, or the technology, or the controls, or the cold hard cash. But the number one reason Sysco was successful is that they created a culture of energy accountability. And without that accountability, it doesn't matter how good the ROI is, the projects just might not get done. So fundamental to achieving energy accountability was having great performance tracking to hold people accountable to results. And so this story is a case study on the importance of creating energy accountability via performance tracking. So in this presentation, I'll discuss the key characteristics of Sysco's energy management performance tracking, and I'll discuss the applicability of those characteristics to a different world, the world of demand-side management program, strategic energy management, and pay-for-performance programs. So why are we connecting a corporate energy management program to DSM programs? As my colleagues and I reflected on Sysco's success, we recognize the parallels between Sysco's journey and some of the pain points of SEM and pay-for-performance programs today. As a major implementer of industrial SEM offerings, Cascade knows that a key pain point is data management for continuous performance tracking. And lessons learned from Sysco are applicable as SEM programs scale larger. So some of you in the audience might be managing programs that you want to scale, perhaps to hundreds of customers, and reaching more customers is a great outcome for industrial DSM programs. Sysco has 142 facilities in their energy program. And every month, they track energy performance using roll-up reporting that's shared up and down the organization. And those reports need to be consistent, clear, fair, timely, and trusted. Sysco leverages this performance tracking as a foundation to create leadership-driven accountability and promote culture-changing habits. So for the SEM and pay-for-performance administrators in the audience, imagine delivering trusted performance reports every month to 142 participants. You need a really good data management and reporting system to pull that off. But if you don't manage the performance tracking, how many of your participants have the time or knowledge and motivation to generate an efficient performance tracking system on their own. That's the whole reason they signed up to participate in the program anyway. And how much energy savings and persistence might we be missing out on by not using performance tracking to generate more energy accountability? So that's why this paper and presentation is connecting this Cisco case study to DSM, SEM, and pay-for-performance programs. You might be able to manage 10 participants with performance spreadsheets, but Cisco provides a blueprint of how to scale up to 142 participants. So energy management programs are growing. In the DSM world, strategic energy management is growing. And as these programs evolve towards an emphasis on continuous engagements, programs will transition from managing dozens of SEM customers to hundreds. And our observations from working with SEM participants around the country suggest that the traditional labor-intensive methods of delivering SEM, like in Excel workbooks and decentralized energy data collection, can't scale reliably and cost-effectively at those levels of participation. There's simply too much data. And key mid-sized industrial clients just don't have the time or expertise to implement a better solution themselves. And in some ways, Cisco facilities are actually a decent proxy for mid-sized industrial sites. They use about 4 to 10 million kilowatt hours per year, and they have a heavy industrial refrigeration load similar to the process loads you might see in food manufacturing facility. So what's at risk for Cisco and others? First of all, savings are at risk. Without energy accountability, without putting credible performance tracking into the hands of their people, Cisco's program would likely have been less effective at saving energy. Persistence is certainly at risk. For Cisco, if performance reporting shows backsliding for 2 consecutive months, that facility gets put on a watch list and gets extra support to recover. And then additionally, a lack of performance tracking puts the entire program's credibility at risk. If an SEM or pay-for-performance program can't get timely data to report on performance, it erodes the overall credibility of the program. Because if you don't believe in the reporting, you just start ignoring it. And we do recognize that a case study on a program across a single corporation is not necessarily a one-for-one comparison to DSM-sponsored program. But despite the differences, a corporate-driven program and a DSM program with various participating facilities all share the simple characteristic of a group of facilities who have set out to achieve an energy savings goal, mostly on their own, with support from coaches and peers. So how does Cisco actually save energy? They do so through a combination of retro commissionings, training and behavioral change, mechanical and lighting retrofits, and efficient new building design and construction. But this presentation is really focusing on energy performance tracking. So how does Cisco track energy performance? They retrieve near real-time 15-minute interval electric data through data acquisition hardware installed at their facilities. And I'll point out that Cisco really has not invested in sub-metering. This monitoring is being done at the utility meter level because the purpose of Cisco's metering is to generate accountability, not diagnostic capability. Sub-metering is a lot more expensive to maintain and install, and Cisco just hasn't seen the value of that sub-metering. You don't need that sub-metering for energy to create accountability, is a lesson that Cisco has learned. Cisco also pulls in weather data and inbound and outbound case movements on a daily basis, which we call production. And they follow a top-down measurement and verification methodology that meets IPMVP Option C and ASHRAE 14 guidelines and aligns closely with best practices found in DSM programs. And all this happens in a centralized system for the 142 facilities in the program. So as we analyzed Cisco's success story, one theme appeared. Cisco uses energy tracking to create an accountability structure for energy performance, which we've called energy accountability. Cisco holds people at the corporate, regional, and facility levels accountable for achieving efficiency goals, all the way up to senior vice presidents and down to refrigeration system operators. And over the years, through testing and iteration, our team has found that 5 characteristics have emerged as requirements to create lasting and effective energy accountability at Cisco. And these characteristics are analyzed in more depth in our paper. The first is consistency. Tracking and reporting can't be a flavor of the month. For example, Cisco's performance reporting has maintained the same metrics since 2015. Clarity is the next characteristic. It's important to define success plainly and don't move the goalposts. Cisco's reporting focuses on dollars and percentages, not kilowatt hours. Fairness is important. Fair performance tracking is an excuse eliminator. Unfair performance tracking just breeds excuses. So for example, if you compare a facility with LEDs and an efficient ammonia refrigeration system to a facility with T8s and packaged rooftop refrigeration units, the older facility is never going to look as good as the newer. And that's what Cisco did back for many years. They used to rely on an energy per cubic foot ranking system to compare facilities across a region. And it did work really well. But over time, we saw a trend appear that the top 25% of sites got tons of credit, they got fawned on, and then the bottom 25% of sites got prodded, but everybody else in the middle, the remaining 50%, didn't get much attention, and they didn't have motivation to improve because they knew they could never get up to the top of the pack because the top of the pack had brand new facilities with shiny refrigeration systems with all the bells and whistles built in. So instead, Cisco transitioned to use a metric to focus on benchmarking plants against themselves. So now when plants were forced to improve against themselves, they had more motivation to do so. The next metric is timeliness, or the next key characteristic is timeliness. And this is straightforward. We know that new news is more powerful than old news. So key Cisco reporting is submitted to stakeholders 2 weeks after the end of the month. And so it can get up to that vice president level 2 weeks after the end of that monthly reporting period. And that's in addition to some daily and weekly reporting that goes to site level stakeholders. And then the first 4 characteristics build trust, and accountability is impossible without trust. So how does this align with DSM programs that are claiming savings on an annual basis using similar top-down models? So when a top-down model is used for savings verification, that end of the year verification process is critically important. But when performance tracking is only viewed in the lens of satisfying that annual verification, the program misses a golden opportunity to create energy accountability and culture change along the way. So of the 5 key characteristics we found, that timely energy tracking is perhaps the most relevant accountability characteristic to DSM programs. And timely tracking more generally means a complete data set and scheduled, frequent distribution of reporting. It represents a shift from end-of-year savings verification reporting towards continuous performance tracking. So I'll shift gears and talk about how Cisco manages performance tracking at scale. Until 2012, Cisco's reporting was performed using Microsoft Excel workbooks. Managing the program felt like repainting the Golden Gate Bridge. As soon as a monthly report was complete, it was time to start on the next month's report. And I'm sure many of you in the audience have felt a similar pain point. Today, Cisco's energy management program processes over 17 million rows of data per year and tracks over 6,000 active or completed energy projects. So to improve reliability and control costs, Cascade Energy proposed a switch to using a combination of 2 software platforms as a system of record for savings reporting. A specialized software platform developed by Cascade Energy called Energy Sensei, and a commonly available data visualization software package. And the inputs are 15-minute energy data from data acquisition hardware, weather data, production data, and energy project information. And the outputs are daily, weekly, and monthly performance reporting at the site, region, and company level. So I'll show a couple examples. This first example is a monthly site report that can help it can help the program identify an underperforming site and help steer them to technical assistance. So for example, in this report, this is showing a fiscal year of July through the following June. And in August, there was a retrocommissioning event that caused some really good energy savings shown by these columns. The savings are being measured against this black line, which is the monthly goal that the program sets for the site to achieve in terms of percent savings improvement over baseline. So they're doing really well for 3 months after this retrocommissioning event. And then something happened in November and the savings dropped. So very quickly, the program knew something was wrong. And by December, the site was clearly backsliding and received extra support to get back on track. And eventually they did in the next fiscal year. So more granular and recent data is always accessible and is pushed to key individuals like this report that gets sent weekly to site facility managers. They appreciate this heat map report. And then here's a representative example of a regional report, a roll-up report that helps regional managers understand who deserves kudos and who needs some help. So I want to circle back to the applicability of this case study to DSM programs and talk about some of the limitations involved and how to overcome them. So if you're thinking this is a great case study to share with SCM participants, so they're motivated to set up performance tracking, cut their energy use in half like Cisco did, please do so. But in our experience, most SCM participants don't have the internal systems, knowledge, or commitment to self-generate the consistent, clear, fair, timely, and trusted energy performance tracking that's necessary. And Cisco hired a third party to deliver this reporting for those exact reasons. So one limitation is that data acquisition and baseline modeling poses huge challenges in DSM and corporate energy programs. Managing all the inputs and outputs is difficult. Even if smart meters might be installed, but the data might not be easily accessible. And then complex industrial facilities can be extremely difficult to model. There's some systematic limitations. More and more utilities might have the smart meter data to provide high quality 15-minute day behind energy data, but there are still structural limitations for third-party contractors to acquire this data. There was a 2020 ACEEE survey of 52 utilities, and it found that most were underutilizing that AMI data in their energy efficiency programs. And finally, cost effectiveness concerns can make performance tracking unfeasible for some programs today. But implementers are consistently innovating to reduce costs and drive more savings and create longer measure lives. So these challenges are real, but implementers are solving these problems every day. And we already have to do a lot of this process already in DSM programs to claim savings at the end of the year using a top-down model, which are inherently the same models that underlie Cisco's performance reporting. So to conclude here, Cisco has created energy accountability through their organization that has contributed to impressive results. They've cut their energy use in half since 2006 on a per cubic foot basis across 142 facilities, avoiding over $300 million in energy costs. And their energy performance tracking fostered this culture of energy accountability, and consistency, clarity, fairness, timeliness, and trust have been the key characteristics of that successful performance tracking. And we believe that this story is applicable to a broader energy program design, including SCM programs across a range of participating facilities. And I'll just end with my contact information and paper information. This paper was actually first published in the 2020 ACEEE study, and we're grateful for the opportunity to present this topic here. Thank you.
Yeah, thanks, Zach. That was another remarkable presentation. I was taking notes here, and I think the summary slide sort of captured my notes almost to a T. 50%, that's a big number. 300 million, that's another big number. And then, of course, the ideas of consistency, clarity, fairness, timeliness, and trust. So I'm looking forward to that dialogue later on as well. So our third and final speaker is Philip Thomas, speaking on the Facility Performance Index, something that I'm personally very interested in. Philip is a graduate of the University of Central Florida and the University of South Florida. He specializes in applying data analytical techniques to industrial and manufacturing plants to generate production insights that improve plant productivity. Core Watts is an innovative idea that uniquely blends the key requirements for industrial and manufacturing advancement in a way that is easily applied and understood. It accurately combines production information with associated energy consumption, yielding a metric that will transform the way industry operates. He has chaired the Big Data IoT track at the Association of Energy Engineers World Energy Engineering Congress, and has made several presentations regarding the ISO 50001 energy standard. He has published articles, including in a 2013 ACEEE Summer Study, Energy Management, ISO 50001, the most vital but missing link in the energy saving chain, and the AEE's International Journey of Energy Management, Analytics, Digitization, Management Systems, and Energy, the Perfect Storm, Transforming How We Operate. Core Watts, which he'll elaborate on, has saved tens of thousands of dollars in annual savings in a poultry production facility. He is a pioneer in this new technological field, which is facilitated by his experience in plant engineering, working at companies such as Procter & Gamble, Cable and Wireless, and now Real Decoy, and energy efficiency initiatives with national and international bodies. The floor is yours.
Hey, John, thank you very much for that. Let me just get my screen set up here. You can just confirm that you're seeing my presentation. All right. Afternoon, everyone. I just want to say thanks for ACEEE for having me, and just greatly appreciate being a part of this panel. And thank you again, John, for those kind words. Well, I'm excited, very much so, especially for the presenters who preceded. Todd and Eva, really put together some core points, as well as Zach, and coming out of it was a whole matter of tracking, being able to have data and being able to utilize the data in a manner that is going to bring about some fundamental information to the wide-scale participants that demonstrate what is really happening with the respective plant. How do we manage, as I think it was Zach who mentioned, these complex facilities for which there are many processes simultaneously occurring, many areas that are disparate, essentially different, and yet still we are being called upon to, bring about efficiencies throughout them all. And so, as I heard these two presentations, I was like saying, Philip, you could have really just, formulated an entire presentation based simply on just what went before, because the ultimate, idea behind the FPI was just in the matter of how do you really bring such a complex environment, bring about a metric that can be very much easily applied, not only, and I think it was Zach who mentioned, internally within the plant, because how can you, be taking these large facilities and then comparing them, as you correctly mentioned, Zach, with a small one, and fairly have that being able to be done. And so that middle section gets they just get left out. The top ones get all the accolades, we're doing well. And the bottom one, and just before I go into the meat of it, I want to just consider one of the metrics Zach had mentioned, the energy per cubic foot. Because that was also part of this whole matter of the FPI. because using the matter of the traditional way of generating efficiency metrics can lead us down the rabbit's hole. So let's get straight into it. This is really phenomenal, and I'm really excited about what went before. All right, so that's just part of what I have to do here. So core what's, and John, thank you for that. Working at a poultry facility, it started out with of a dashboard. They were enamored. They saw it and they said, "Well, Philip, I'm bringing the ISO 50001 program, and I'm saying, guys, you need this. This is going to help to rationalize all of your energy production, and you're going to be able to just demonstrate where it is being produced and how it is being produced and what the whole matter of significant energy uses." And can you imagine? I'm like looking at the faces and I'm saying, I don't understand it. I mean, I'm bringing some novel information here, and there's these people looking like they're getting bored. And I was asking, what am I going to do? And so I said, oh, let me just try this dashboard. And bingo, their eyes lit up. And I'm like saying, wow, of all the things that I at least expected to generate some excitement, it was a dashboard. So having done that now and gotten my leg in, started recognizing that, hold on a minute here. These companies have data, but the data is coming across varying streams. Production persons have it. And this, I think, goes across any plant. What Cisco is doing, what Bonneville is doing with Todd and Evil, I think it's the same situation. Production persons get data. Maintenance persons want to keep the plant running. And several industries who actually gets the utility information, guess who? The accountant, because they're getting the utility bills. And so here is some valuable information I'm discovering. And the notion of it being coalesced and put together, there is no individual given that responsibility in these plans, because it's just not taught in the universities, it's not evolving, because everybody is doing their individual stream quite efficiently. The plant is running, the utility bill is being paid, the production line is getting, the products. And at the end of the day, however, persons are saying, well, what are we going to do to make our place more efficient or make it better run? And so we get initiatives like the Industry 4.0, we get the ISO 50001, and we get these vigoring, the strategic energy management, and we bring it. And at the end of the day, persons look at it from their individual siloed areas, and then they begin to implement similarly. But can you imagine what was coming out was the fact of, hold on a minute, if we could find a way, as I think it was you, Zach, who had mentioned, from being able to consistently, not on an annual basis, being able to bring the respective variables together and generate a metric that gives the fundamental, what are you going to call, efficiency of the plant, that is easily appreciated, easily understood, gives that measure of fairness that you had mentioned, and to Todd and Eva, the matter of the clarity. That's what was core what's about. Let's continue. So what are we going to be talking about? I gave a lot of the background, didn't I? But the background, the significance of the ENPI and the FPI equations, the application and benefits. Think of all those prior two presentations and just consider now what you're about to hear and why I'm just so excited about bringing it, the implementation and how it is implemented, and of course, a conclusion. So, confined data. Production persons are getting production information. And they are basically having from sales, needing to be able to satisfy. So it bore out of a poultry production facility. And of course, when sales comes in and says, listen here, we have our seasons, we want to get the sales done, and production has the numbers to meet. Maintenance engineering, what are they getting? They just, the downtime. They are having their foot to the pedal in the regards to making sure that equipment is running. So the whole matter of efficiency is one aspect. We are getting paid based on, or deduction based on when the plant is not functioning. So that is their whole matter of, that's their main criterion. And then now you have that accountant sitting and says, okay, here we get this utility bill. What do we do? And we pay it. And so at the end of the day, everybody's doing their work. And the funny thing that happens now is that several times you find that If things don't work out well, you know what we have to do? Outsource. Or go to another nation. We won't bother to mention names because there the labor arbitrage is cheaper. But the fundamentals of the plant, do recall what Zach had mentioned. The top tier persons with that fabulous, they have the shiny equipment. And just simple math. When you're able to increase production, just, the numbers, invariably that energy per cubic foot is given a lovely term because you are able to offset efficiencies by more numbers. It's very deceptive. And that was one of the hallmarks, by the way, everyone, of the ISO 50001 program, in terms of it being able to demonstrate what it is that persons are doing and the matter of the fallacies in terms of the metrics, several times of how it's being presented. So just to ensure that everybody's familiar with where we're coming from here, the accountant, the production manager, sales, these persons are getting vital information, but it is in the context of what they themselves are responsible for. And because therefore there is not any driver to be able to coalesce this, much less to be able to discover what happens when it's going to be put together, each person is within their own sphere doing what they know and seem best. And at the end of the day, when initiatives arise, for example, case in point, 4.0, sensors come in. This happened very regularly. Persons who are here on this, on viewing this, persons would come in and say, hey, we have a device, we have an IoT device that is best for your facility. And they would run in and they would come in, and remember, these persons may not have any idea of how the facility really operates. But they come in and say, okay, now we are going to be able to just showcase this, and we want to be able to put this in, and let's go to the warehouse. No, guys, if you're into refrigerated facilities, you know that refrigeration is one of the biggest consumers of energy. So where you want to put these lovely devices would be in the cold storage areas, much as blast freezers. They're the ending of going into the dry warehouse. Does it save money? Yes. But at the end of the day, when you're dealing with that environment of where we are with this global competitiveness, you would have to ensure that the millions or the hundreds of thousands of dollars that you're putting is where the bang for the buck is greatest. And so what happened is that these vendors who come with very good intention, because they are not having the means by which to understand the playing field of what they are coming in, look for what they know best, and at the end of the day, who suffers? The company, because even though they may have an incremental increase, it's like what Zach was mentioning, they are still caught in that middle band because they can't demonstrate why they have not gotten where they should or expect to go. And two, they are not being even necessarily the respective, information on how to be able to get to the next level. And so with that, there is a whole realm of saying, okay, what do we do and how do we go about doing it? And here is why the FPI was born. Because the FPI is a Facility Performance Index. You're going to see it. You're going to see what it's about. You're going to see how it looks. It brings the core units together, achieving a metric that brings light to productivity potentials within the respective companies and within the respective firms. And it is therefore able to bring a whole new aspect to what was being said before. Day-to-day accountability of what is happening and what needs to be done. And at the end of the day, also giving persons, not necessarily even in the manufacturing sphere, an opportunity of getting a quick and easy understanding of what the potentials are, and then being able to so apply. And furthermore, being able now to do the internal benchmarking with the external, and the list goes on and on, which you will see as we go along. Okay, so let me just quickly get something done here. So the data, the responsibility, the expenditure. You have the data, but it's in different silos. The responsibility, each person is doing their respective area, and the expenditure, it's just been a matter of money being put together for these various initiatives, and at the end of the day, not being able to be maximized because the aspect of how to bring in all of that disparate information is not therefore being able to be done. And so said, so done, you get lost opportunities. Now I'm going to show you the next slide, and you're going to be many of you are going to smile because, it's not as if this little simple equation, which everybody I believe knows from, may I say, primary school days, or I think you call it grade. I think it states counts like grade 6 to the K-12, the early we call it primary school back here in Jamaica, but the early ones, or maybe high school. The y equal mx plus c. Not a Fourier series algorithm or whatever. But I want to break this down because ISO 5001 said the following. In energy consumption, you need the following. You have the y is the energy output, fair enough. You have the efficiency metric being our m. The variable could be production. I think it was either Todd or Eva or Zach who mentioned the matter of what? Weather. Data also included for also primarily production, because thankfully, where we are, the weather is not very much of a wide sequence, but that would also be inclusive. But this is the kicker to it all, everyone. When you use an energy per cubic foot or any other metric like that, what it's basically saying is the plus C, the base load, is out of the equation. It's zero. And if you start wrong, where do you usually end up? There you go. And so what the ISO 5001 was so instrumental in doing is getting an accurate, what they call energy performance indicator, KPI, for the matter of how energy is to be monitored and reported. Just a quick thing. So as you said, Zach, you have a large firm, you could have a large piece of equipment, and you have a smaller subsidiary elsewhere. And the smaller subsidiary hears from the large firm, hey, get this piece of equipment because we have had phenomenal, results. When you put that lovely piece of equipment back in the small firm, they're like saying, what, you just killed us. And they're saying, why? We don't understand. How can it kill you? Because the base load went in that large facility is offset by the larger production quantities, if you get the point I'm making. When it's put in the smaller facility, once they turn it on, they just don't have the amount, call it break-even analysis, if economics terms are better understood, to be able to make up for that large quantity of the base load. And so therefore, the whole dynamics of the piece of equipment, while it was benefiting in the large top tier, is catastrophe for the bottom. And maybe for the middle, it just keeps them in the middle. We have to get an algorithm, well, not an algorithm, a metric, first of all, that captures truthfully how to measure and monitor in our energy framework. And ISO 50001 did a phenomenal contribution. I don't think it has been, what are you going to call it now, marketed or presented forcefully as how it really should be, but that was one of the best one of the good contributions. So having with that metric and established, what we saw was the following. Can we take that and be able now to populate it daily? And being able to populate it daily, what would we find? It was magnificent. Because what it demonstrated now, and you soon see the graph, was the base load coming out and a true efficiency metric coming out. You remember the M and the plus C? And so having seen the base load by itself, because remember, base load represents the energy consumed when the plant is not producing, we began to say, hold on a minute here. Are you saying to me that this is what is happening? Listen to the train of thought. So now you're getting accurately the dynamics of the plant. Simple. Anybody can understand that, the plus C, when they recognize what base load is. So the person began to say, so why is that? So we went into the production line, and guess what we found? The production line, by the way, we also found that one piece of equipment called a post grind was 25% of the entire consumption of the plant. Can you imagine that? So they were going into LEDs and all these other things beforehand and not recognizing that one piece of equipment was not LED light. was accountable for 25%. Can you imagine that? So the plant manager said, Philip, before that we were investing in so many of these areas, but let me not go off on a rabbit trail. So having with the base load, they recognized that they would produce, pause, the equipment is continuing to run, and then another batch comes in. And the first thing we said, so hold on a minute, let's get more, it's a batch process, let's get more of these batches and take down the interval. It meant some, obviously, with the matter of the ingress of the raw materials, but that was nothing. But the other thing was now to be able to see whether the type of operation was in fact what the equipment was made for. Because, when you have increase in start and stops, start and stops can be problematic maintenance-wise. When they inquired about the equipment manufacturer, they were told that was how it was meant to be, because for small manufacturers, we recognize that, and that was how it was intended. Hundreds of thousands in savings with just a tweak in an operational, what do you call it, order, what they put in to do their operations. Phenomenal result. And so what we are finding, therefore, is that take, for example, a plant. You have your FPI. When it is new, you are now able to say, as what you talked about, Todd and Eva, at each application, when the thing is aging after a retrofit, is it being returned to what it was when new? If not, what's happening? That's just one thing. Raw materials, when it goes through the respective process, how is that being related to the actual operations of the plant? The matter of new equipment ordering, you then find out and say, okay, no, so you have this piece of equipment, okay, in your plant. Let me just do some, you have any energy information for me? You have any production information? Let me start doing some checks on my end. And then you find this humongous base load, which you wouldn't have known before, by the way. And then you say, you know what? It would be a lovely thing to have it, but I can't take it right now because it's not for me. And the person say, well, what do you mean? Well, we have done our checks. And so it provides an easy way of the plant overall function. But as was also mentioned, it is also able to quickly be utilized along the plant chain, from the facility level to the process level to the individual equipment level. All three are captured through the FPI. Let me see if I can get to the slide. So I talked about this future application. So, we have like pump curves. I see where with this, and the matter, my time is almost up, I see, but with this, we can also start doing a similar FPI curve per equipment for the respective manufacturers, so persons are able to understand even clearer how they're able to apply what they produce with their respective products. So quickly, how to adopt it, because I know many of you are asking this question. Define the scoped area. Determine the point of access. You mentioned, I think it was Zach, in terms of the matter of accountability for Cisco as opposed to the matter of it. Well, with this, they can accomplish both, and they would be able to do it quite easily. So you're bringing the energy and the respective quantity. And what happens now is that, and again, ISO demonstrated this with the linear regression, being able to combine the two and then map the readings to the manufacturing cycle. And how does it look? Well, everybody's familiar with this. This was a raw data that we had to bring in. So you have kilowatts, kilowatt hours, and the production information. But here is how the FPI comes out. And just before I close here, can you imagine when we had this type of data coming through? At one point in time, we found that the efficiency was just coming off the chart. And we're like saying, what in the world is going on? This can't be. Something is wrong. And I went to the maintenance person and I said, well, Philip, we have done our checks and we don't see anything happening. What are you talking about? But I said, no, yes, I hear you. The amperages are all right. Everything is okay. But why would the efficiency just continue be just climbing for no apparent reason? In that case, it was a matter of degrading, not when I say increase. I'm confusing some persons. So the whole aspect of it was using more energy, so it was actually a decline in performance. If you get the point I'm making, and I'm like saying, do you know what happened in the end? Air compressor went out. Now, okay, this was when we're just getting into the whole of this. So persons were kind of like looking at me skeptically when I said them something was going wrong. You know what I mean? They're like saying, oh well, what's he? He's just making all this stuff. Air compressor for the entire plant. So in concluding, minimize waste, enhance public decision making, save energy, minimize greenhouse gas emissions. I heard a presentation by Joy Pixley. She was mentioning how, small and medium manufacturers are being bombarded with all these technologies. How do we go about it? What do we apply? And she was like saying there is so much going on. Nobody really knows how to handle all of what is coming. And yet still everybody recognizes that there's something out there which says all of what is being said needs to happen. We just can't find what it is that's going to help us to guide to us appropriately from one step to the next. I put it to you that the FPI will help greatly. And the matter of this, having borne out the ISO 50001, we are guaranteed of its accuracy, if not, that's not the best word I could use, but it's being verifiable and applicable to respective industries. It has been a great pleasure today, and I look forward to any questions, and I am so happy to have been here. All right then. Thank you. Over to you, John.
All right. Looks like we have time for some Q&A. There were a few questions populated in the chat box. We have time for a few more. So as we go through these, please, to the audience, don't hesitate to share your questions with us. We've got a great set of industry luminaries here that can respond in their best appropriate domain here. So one question for you, Zach. For larger corporations, it is sometimes difficult to push organizational policies down to the broader organization. Were there any specific strategies that Cisco applied to mitigate the issue and achieve success at the broader organizational level?
Yeah, it's a great question, and a few things come to mind. So a couple simple strategies. Participation was mandatory, not optional. We've seen in other organizations that we've worked with that decision will get pushed down to the facilities to decide. But in this case, it came all the way from the president of Cisco at the very beginning. They have, another simple strategy was to tie part of the plant manager, or basically the facilities manager, variable compensation to energy performance, to hitting their energy goals. And it was never much, but it was just that carrot for them to hit goals. And it really put pressure on the program to get it right, because people's financial compensation was at risk if we got something wrong. And then another key strategy that comes to mind is that the program started with their broadline distribution centers, which was about 100 in North America, used, at the time, maybe averaging 8 million kilowatt hours per year per facility. And then once credibility was established with that broadline division that had the built-up accountability, only then could we go pull in the specialty divisions that didn't quite have the same accountability structure, because they were hesitant at first because they were skeptical. They said, we're smaller, we're different. So we had to wait to get the to get the results first.
Outstanding. While you sort of alluded to incentives, Steve Schultz posed a question around what kind of incentives did Cisco offer to the high achievers, if any, I guess.
Well, I did mention the variable compensation to facility staff, to key facility staff. There was a lot of sticks, maybe not as many carrots, but there was just sort of a mentality of, hit your goal, get it done. And I guess a key incentive was just visibility. You were getting regional reports with your peers in your region, and you wanted to be green, not red.
I like it. Well, I don't know if I like it or not, but it's clear that carrots and sticks both work. So clearly they got the results they were looking for. So a question for for you, Philip. You had recommended a machine learning model. Do you need to have production data at the same level as the energy data? Often that's at a daily or weekly or monthly level. Can you use your analysis with production data that's less granular?
Certainly, John. And what can happen if it's less, if it's more or less granular? The thing is, you really want to tie in the energy consumed with what it is being, aligned to. And that is critical because that is therefore going to bring what is going to generate, for example, the base loads and the respective efficiency. So you just don't want, and the greater, conglomeration of the production, then you are actually going to be, what are you going to call it now? Bringing together certain factors that are not going to come out. So the more granular it can be, it is definitely going to be better for you. And the more you can associate the energy consumed with that respective production, and then being able to put that into the machine learning algorithm, it's going to be even more insightful for you. It's like when you have integration and you're just being able to just, get an overall picture. It's that type of thing I'm talking about. So the more granular it is better, but you definitely want to tie that in the matter of whatever energy is consumed, what process was it consumed with and by.
Outstanding, thanks. So Todd and Eva, I'm going to put you on the spot. You had some phenomenal images in your presentation of shall we say, legacy equipment. And you talked about things that were really largely not about technology, but I want to just poke a little bit at the sort of juxtapositioning of the role that technology plays, even in the scenario you're talking about in terms of the requirements for successful programs like that. So if one of you wouldn't mind just kind of commenting about what role technology can play.
Eva, would you like to address that?
So there's a technology that is the capital project upgrades, which of course is where a lot of our work goes, but sort of to Philip's and Zach's point, the technology that's coming in that I feel like is really going to be a big difference is the monitoring and measuring and verifying. Because, your operators know if they're making their widgets, but they don't know if the widget is costing them, how energy intensive is this widget versus if we made this change, would it be less energy intensive and ultimately cheaper? Because as somebody said, I think it was Philip, that information's siloed, right? That the operator doesn't pay the utility bills, doesn't see the utility bills. His metric is probably production or lost time or something.
Right.
But tying those together. So I think technology in measurement and just controls and the way we can distribute sensors now and pull that together is going to be one of the huge things. I'm not sure if that's what you were asking about, but that's really something I see that's huge. But of course, along with those systems, you have to have someone who runs it.
Yeah, I think that's a great response. It's consistent with what we're seeing as well. Just the need not just to understand production data or energy data or maintenance data or quality data. The opportunity to kind of look at them in less siloed ways and in ways that are contextualized, and that gets back to some of the things you talked about. I think Zach, around being fair, right? Having KPIs and measures that are fair and that are realistic and achievable. So anyway, thanks Eva. I think that's a great observation. There's a question that came through, I think, for Zach. How could the lessons from challenges like with the BPA examples help developing approaches to evaluate tools or technology to automate or scale effective data and report management, or translate approaches like Cisco's across other organizations?
Yeah, and Eva and Todd, feel free to also jump in on this one. But my thoughts here are that Cisco is, in some ways, idealized compared to like mixed industrial facilities. I mean, they're say about half their energy use at any given facility is in a central ammonia refrigeration system, and then you have a bunch of other subsystems. But working with some of the like ESI customers that Todd and Eva are working with, though, a paper mill is a whole different beast, and you can't just build a facility model and expect to understand when an operator changes a set point that you're going to see the results. So So I do think some of the lessons learned from ESI around doing deeper dives into doing some more sub-metering on this, or temporary logging or permanent logging on a smaller piece of smaller system or single piece of equipment, or focusing deeper and deeper and deeper, is a really good lesson learned to apply some of the Cisco success story to more complex facilities. And then it's a matter of how do you do that cheaper, and how do you scale that? How do you scale that sub-metering? How do you keep it running? People often think, oh, we'll just install a sub-meter, but there's a real cost to keeping that running. They don't always work. They break. There's a cellular communication fee. So who's going to pay for that? And how do you show the value coming from that? But it can be done.
Thank you. Before I move on, Todd or Eva, any additional comments on that?
I was actually going to piggyback on that, Zach. When you're talking about the systems, I mean, we have all this great monitoring technology, but if the sensors go bad, it's not giving you useful information and might actually be giving you worse information. And that, I feel like, is one of the things that fails most often in projects that fail that I've seen, is something really small, the small component. You know, the whole system needs you to get accurate information. I think that was your point, Zach, that if the information coming in is garbage in, garbage out. So there's a lot of little pieces. You can't just buy one magic device and have your system work.
Yep.
Yeah, I would echo that. That wood products example we shared, we actually had a pilot where we did co-fund, sub-metering equipment with data acquisition systems. And it was, high hopes for the future, but for that wood products facility, it was overwhelming to them. And there was always red lights flashing, something wasn't working properly, or often wasn't. And so, yeah, they ultimately did go to that full QSUM dollar performance metric to, compare how they're doing month after month. And I have hope for the future, and we will get there with these, sub-metering capabilities getting cheaper and cheaper and such.
Great, thank you. So, a question for you, Philip. Is the index relative to the plant baseline or a general expected performance level?
Great. So, what does John to the baseline? Yes. And also in regards to, but what we did, we treated the baseline with regards to consumption per month, separate and apart from what was going to be generated from the algorithm. So we saw the whole matter of the algorithm and the FPI as a monitoring and tracking tool, and then being able to say from that, how is the baseline affected? And then the correlation between, okay, this is increasing or that's decreasing, and therefore then you're going to find that it's going to be affecting the baseline, adversely or in a positive manner. That was how we treated it. And if I just backtrack just a little bit on that. So, as and what Eva was mentioning, so when you have this type of information coming in, John, you're able to therefore detect what it is that is the normal or the best or the expected operation of the piece of equipment that has been producing that baseline, and then being able from the deviations to be able to account for readily what happened yesterday, what happened the day before, versus you get an accumulated amount of information and you're lost as to what was the exact response. And that's one of the nice things about it in regards to, you do something on the initiative, you retrofit a piece of equipment or you put in a new bearing, and then you're able to say, hold on a minute now, it had that effect on the plant, and then being able to tie that activity to the respective outcome.
Got it. Great, thank you. One last question here before we wrap up. This is going to go back to you, Zach. I assume that energy costs are a significant percentage of operating costs at Cisco. Do you have a feel for what percentage?
Yeah, actually, off the top of my head, I don't have that number. It's actually not exceptionally high. We work with other multi-site customers who energy is a higher percentage of their operating costs that have varying levels of success creating energy accountability. But for Cisco, you see their tractor trailers on the road burning diesel, and their diesel cost is higher than their facility electric cost by a large margin, I believe. And that hasn't stopped them from really digging in. And even if it's a small percentage, at the scale they're operating, their spend is large enough that it's important to them. So sorry, I don't have a specific answer for that.
I appreciate that. Well, let me just remind everyone that there is a kind of an end of the day post-panel debrief session. I think it's at 5:15, so come back. It's a different link. I think it's a Zoom environment for that. But come back, join us either, and there's different breakouts that you can attend for either the speakers that are part of this session or some of the others, your choice entirely. So if you have time, please join us there. Other than that, let me just thank the speakers here again. Todd, Eva, Zach, and Philip. I think your presentations were outstanding. Thanks for investing in the time to put the papers together, to build these presentations and share them, and look forward to seeing you later. Thanks all. Take care.
Thank you.
Thank you. Thank you very much.
Thanks, everybody.
Bye.
Bye, guys.